Well, good evening, everyone. How's everyone doing? Well, a warm welcome to everyone here and online. My name is Adam Hems. I'm the leader of the group along with Kim Vaddy, my co-leader right there. There she goes. How many noobs do we have today? A lot of familiar faces. Okay, Kristen's a noob. Are you the only noob? Everyone else familiar? You guys, yeah, you guys. A little while ago, it's been a few years for Robert. Some regulars. Ray's here all the time. Ray's only here for the pizza. I'm just kidding. Just kidding. Well, in that case, a warm welcome to Kristen, our only noob, maybe some new folks online then. So I've been running this group since 2016, and Kim's been helping me out for feels like most of that time. Family affair, Kim's kids out on the front right there. So it's a team effort. It's a hobby, if you will. We all have day jobs. My job is a consultant for a company called 3Cloud. Kim is at Microsoft. But we talk about Azure all day, every day with customers, and that's what we like doing in our professional lives, right? But this is an opportunity to get to know folks on a personal level, to chit chat, to chin wag, to share technical knowledge, not just the speakers and ourselves, but also an opportunity for yourselves to get to learn from one another, right? Lots of industries. We've got lots of oil and gas representation. That's very common. Medical science, a lot of consultants like myself, folks from retirees like Ray with a lot of experience to bring to the table. So it's always interesting conversations. Really highly recommend if you get a chance to chat with one another, because there's a lot of very interesting people in this room, I can tell you, because I know many of you and they're very, very interesting. So that's part of what this group is about, and it's not about sales pitches. We do that. That's part of our day jobs very often, right? Not here. This is about learning from one another and from the speakers. So with that, warm welcome. The other thing I'll call out, so the room is mic'd, so chit chat in the back might be private. The speaker won't be able to hear it, but folks online will. So FYI, yeah, the room is live. With that, I'll hand over to our speaker tonight, a returning speaker, in fact, once again, by popular demand, no less, Atul Shah. Go ahead, sir.
All righty. Hey, everyone. My name is Atul Shah. I'm a app innovation technical specialist with Microsoft, which sounds like a big long title. What does that actually mean? I work with customers very early when they're developing an architecture, when they're trying to figure out what they want to do, specifically around apps. I work with them to help develop architectures, do POCs, understand the technology, and then I hand off to another part of our organization. That's really my goal here. And so I get to work a lot with new technologies, specifically AI these days I work a lot with. But I have a specialty around integration and APIs. And so today I'm going to talk a little bit about API management, talk also a little bit about why you should manage APIs, what's the benefit in doing that, and then we'll talk about how API management fits in when you're building generative AI applications, why it would be useful for AI applications particularly, what are the differences, and we'll focus on a couple of different demos. So you won't just see slides, we're going to actually walk through both API management and its use within generative AI applications. Just before I jump off of this slide, if you have not signed in yet, scan that QR code, fill out the form, please, if you can. That helps us make sure that we have pizza for you guys in the future and things like that. That's super helpful. So I'll give everyone just a second if you have not had a chance to do that, but I'll put that back up later on and we can make sure you get signed in. Okay, so we'll talk a little bit about why even bother managing APIs. What does that even mean? Why is it useful? I'll walk you through Azure API Management, which is our Microsoft's API management solution. We'll do a little demo of that, hopefully a little bit fun kind of a demo. And then we'll talk about what we call the generative AI gateway features of API management. And those are the things that are for your AI applications going to be useful to look at and consider when you're building AI applications, especially ones that end up in a production environment where you're serving customers and that sort of thing. And we'll save some time at the end for questions. Yes.
Will you talk a little bit about MCP?
I can talk a little bit about MCP. I didn't add that to the demo. MCP is
I mean, it's something that just came up so recent to me.
absolutely
And I saw Microsoft just had an article like a few days ago.
2 days ago. It's been, if I'm monitoring LinkedIn, it's been like 2 weeks. It has been a very particularly popular conversation. So we'll talk a little bit about it. I'll show you maybe where you can learn more. And I'm gonna demonstrate, we have an open source repo that has a bunch of these generative AI experiments on them. And some of my demo is based on those experiments. And there is an MCP experiment there as well. But we are growing in that space too. I just found today some cool stuff we're doing around MCP and Playwright, if you've ever heard of Playwright. Playwright is like a testing framework that lets you automate like user testing, like clicks on a page. And so we're building an MCP connector to Playwright to do automated user-based clicking for generative AI applications. So giving context via like going to a web page, for example.
Thank you for scrapping.
Yeah. I mean, I don't know if it's really meant for web scraping, but it could be to automate things that are otherwise difficult to automate. For example, something that requires a user to click. Okay, so that's the agenda for today. Feel free to raise your hand, ask any questions. Adam, if you can monitor chat.
Monitoring chat. Yep.
Alrighty. So first part of the discussion today is why manage APIs? What's the point of managing APIs? And maybe before we jump into that topic. Yeah, go ahead. Oh, okay. Sorry. Show of hands, who's working with APIs on a daily basis? Okay, a good portion. If not working with APIs, who's interacting with APIs on a daily basis? Should be everyone in the room. Because whether you know it or not, if you got a notification on your phone today, that's an API that is telling you that something happened, right? And so APIs are very, very ubiquitous in your lives, even if you may not know it. And so one of the reasons to even consider managing APIs is how ubiquitous they actually are. And that is actually growing in the market. This is based on a Postman survey that happens, that they put out every year. And I just put some statistics. So 90% of the survey respondents say that their API investments are going to stay the same or grow this year. So very, key indicator that API investments in the industry are growing. Survey respondents, 50% of them said most of their dev effort is in building APIs. 62% of respondents said that they're working on APIs that make the company money. It was no longer just a supporting technology. It is something that's generating revenue. And 73% increased AI-related API traffic across Postman platforms. So significant increase in the number of APIs being used and traffic related to AI. And what we'll talk about a little later is how integral APIs are to building AI applications. So just to give you an idea of why you should care about APIs. So let's assume we care about APIs now. Why should we care about managing them? Well, as soon as you have APIs at the volume that they're being built now, there's a lot of opportunity for mismanagement. So How do we look at things like cost? We have an API that's out in the public. Maybe we're not monitoring it. A hacker might get a hold of it. Or if it's a free API, it's not properly secured. Some other nefarious actor gets a hold of it and is calling our API thousands and thousands and millions of times. That's going to shoot up your Azure spend. It's going to shoot up your operational load. And so, having some control over the API landscape is going to be something that's more and more important. Additionally, things like reliability. How do I make sure if I have an API that's driving something in my business, or it's part of my app and delivering to customers, how do I make sure that API is going to be reliable? Just like you treat an app, you want to start treating those APIs the same way. We talked a little bit about spend in terms of security vulnerabilities, but there is a whole practice around managing APIs. If you've heard of OWASP, they put out a top 10 set of vulnerabilities specifically for API traffic because of how many attack surfaces are available in APIs. It's the way to get data. How do I exfiltrate data out of the environment? Usually it's through something like the last couple on here are around how do I enable people to learn about the APIs I have in my environment? If you look at that Postman survey that I referenced, in this year's report, one of the things they talk about is how difficult it is to get developers to learn about APIs, to use APIs. Developers are often having to physically check in with teammates, product owners, other parts of the organization to learn about APIs. And if we can enable them to learn about APIs, that's something that would be super useful. Last one there is around how do we, of the challenges that we listed above, how do we make sure that we systemically address those challenges by using governance? And so all of these are kind of the hidden risks or things that need to be considered as we're talking about APIs that are unmanaged. All right, so then if we're going to talk about APIs that are unmanaged, then how do we mitigate the risks around those APIs? Well, we can do a few different things to help us there. And we put them in kind of these three pillars. One is we abstract away the actual API. We put a facade essentially in front of that API that separates it from our actual API. Something that a application is going to talk to, but maybe it doesn't know about the actual thing that's running on my server. We can do things like normalize or modernize those APIs. Let's say you're working in a legacy environment. Who's heard of SOAP? Anyone heard of SOAP? Okay, so 10 years ago, 15 years ago, SOAP was a very popular technology. Now it isn't, right? And so how do we modernize SOAP APIs? Is there a way to do that in a way that's automated, that we don't have to spend a lot of time doing it? How do we make sure that APIs that we give to application developers are not dependent on the thing that runs on the server, or that are disconnected from the thing that runs on the server? And when I say disconnected, I mean, if I make a change to this API that runs on the server because I'm doing some experimentation, how do I make sure that my application continues to run successfully without breaking that experience for that application? I can do things like mock that API to make sure my application, I can still continue to build my application. The middle pillar there is around governance and control. What can we do to make sure that our API access is secure? So very commonly, we'll do things like we will route to specific backend APIs. Those are the things that live on my servers. We'll do things like rate limit our access to those APIs. So we'll make sure that we're not overloading those servers. We'll also secure those APIs. So for example, we'll use, if anyone's heard of OAuth, we'll use OAuth to protect those APIs, or some sort of authentication mechanism. And then we might also do things like transform the shape of an API. Let's say I have an API on my server and I need to know some telemetry about what's happening. So maybe I want to know what's the server name that when I call that API, I want to know which server it's hitting. And I log that somewhere, but that gets sent back in the response to the API. I don't want my users or my applications to know about that. How can I change my API to remove that information? That might be something that I'm interested in doing. And then lastly, obviously, I want observability. I want to be able to monitor my API call from when it starts to when it finishes, or when something's sent back to the application. The last pillar is around discoverability. How do I make my API available to people who need to consume it? Just building an API, it's not going to be called by anything. That's not helpful. And so almost immediately, build an API. I want to publish that to someone who's going to consume it so that my API can get used. And so how do I make that, how do I enable that experience? How do I publish my API? How do I give details about my API? Those are all things that are going to be useful for me and that are going to accelerate developers who are using my API. Any questions before I move on?
So
Yes.
in case where we are using SaaS products and there's the API connection where one vendor is consuming another vendor data,
Mhm.
but the data is the company owned data.
It's your data.
It's our data. So what's the best way to protect that?
That's a good question. There is an opportunity to put an API gateway in the middle there. It really depends on what your vendors offer you, your SaaS vendors, right? If they're gonna, you have configurability, you can stick a gateway in the middle that's yours. There's questions about whether that's gonna add latency and things like that. So those are some considerations if you're trying to go that direction. You could stick a gateway in the middle, and then that could be your observability layer. That could be a governance layer that you want to implement. Let's say one of your SaaS vendors doesn't offer the right kind of authentication that you require or that your information security team requires. You could layer in a gateway to help add that capability without having to change your backend API because you have less control in those scenarios. Does that make sense?
Yeah, and I think we were looking more maybe something creating Azure key vaults. But then I think we just add another barrier, like if the key get changed or something, then we have to somehow manage that. But we are not the owner of the keys, right? Because it's the SaaS vendors is the owner of that key.
Yeah. So API management does integrate with Key Vault. So you could use that as a mechanism. Key management is always going to be a challenge because it is a thing that you have to share with someone. With the developer portal in API management, you can allow for self-service where the vendor potentially could register with your developer portal and get a key. And you have some control over like revoking the key and things like that. So there may be some capabilities around that, but those keys are not generated in Key Vault, they're generated in API management. So I'm not sure if that solves your entire problem. I'm happy to discuss it in more detail for your specific use case afterwards, if you'd like. Yeah.
Does API management help anything with the scaling? Scaling?
Scaling? Yes. Yes, so we can talk a little bit about scaling. We will talk a little bit about load balancing a little bit later. So maybe I'll save that part until we talk about load balancing. You had a question?
You mentioned a company that put out a publication of the top 10 cybersecurity risk for
WASP.
Can you spell it for me?
WASP.
WASP. Thank you.
I forgot what it stands for. Open Web.
I'll ask Copilot.
So one question about when you post a request, API management. The API management will capture the user who is posting the information.
So the question was, will API management, let's say an API gateway, capture the user that posted a request to that API management gateway? Generally, yes. Depending on whether the user's information is part of the request. So, for example, if I have authenticated, then there's probably a token that goes alongside that request. And API management can inspect the token and grab a username out of it, for example.
Basically, the reason is when you are hitting the actual SaaS API, the user who is posted, it should be in the last updated.
Yeah, so for example, a lot of ERPs require user information to go along with the request because of licensing and other things. So generally, yes, if the information is part of the request, then the gateway should be able to understand and pull that information out or reformat it and send it in some other mechanism to the backend. We're getting advanced.
You have a list of what kind of backend technology versus how it can transform into.
Yeah. Let's wait for the demo and I'll show you. Okay. Let's talk a little bit about our product, which is Azure API Management. And I use this slide whenever I talk about API management. I try to show this slide because when you go into Azure, you will spin up an instance of API management, and it will look like one thing. It will look like one service. There's actually kind of three main components of API management. I'll walk to the screen so I can point at it. So you can think of, like, if you imagine a line that goes this way. If I'm an app developer, I'm a developer that's consuming an API. I usually will work with API management in a certain way. Yes.
So sorry, I know it's a little hot in here. They're gonna turn the air back on, so my mistakes, bear with us. They're gonna turn the air back on.
Thanks.
Sorry about that.
Thanks, Kim. Okay. I'm an app developer. I want to discover, learn, try, or access to APIs. The way that I would do that in API management is to use what's called the developer portal. The developer portal is a component that comes with your API management instance, and that you can set up with things like authentication to allow developers to log in and understand what APIs are in your environment, right? So you get a list of all of the APIs. You can see what the inputs and outputs of those APIs are. You can do things like try the API, so you can click a button and send a request. And you can do things like use self-service to sign up to access an API. So to get a key to an API or create a subscription. We'll use the term subscription later on too. So that is what we call kind of the user of API management. Then in the middle, we have what's called the management plane. That's an API, actually. Management plane is an API. When you go into the developer, or when you go into the Azure portal, and you're accessing the portal interface, that's working with the management plane API to show you the configuration of your instance. So that's how you would manage configuration. That's also how you would implement things like governance policies we'll talk about governance policies in a second. But if I'm publishing an API, I'm going to use the management plane to publish that API, and I'm going to use the management plane to govern that API. And you'll see a line between the developer and our management plane. That the reason there's a line there is that when I make an update in the management plane, that update shows up in the developer portal automatically. I add a new API, shows up in the developer portal automatically. So the management plane is where I publish APIs, and I publish governance for those APIs. But what actually does what actually performs the governance? What actually does the routing or the rate limiting? That's the gateway. That is a component that actually does routing. So when I have an app that I've built, and that app needs to talk to my backend API, the way it's going to do that is it's going to go through the gateway itself. The gateway is the last component on this list. Again, there's also a line between the gateway and the management plane. The reason why there's a line there is because when I make an update there, the gateway gets that update. So anytime I add a new API, the gateway gets updated with that API.
Question from online.
Yes.
What is the difference between API management and governance?
They're honestly synonymous. Like there's governance is a part of management or a subset of management. But I mean, you can think of them as synonyms, right? There's security governance, there's reliability, there's versioning governance, there's design governance. All of those are aspects of API management. Those are all management topics. So, I mean, I wouldn't draw a distinction. They're kind of one and the same or subsets of each other. So any questions about what comes with API management? What features there are in API management? Yeah, I've said a lot of words. Let's talk about a little bit about what some of them mean. So what's like the life cycle of an API request, right? So I start with an app, and I have an app to call API or multiple APIs. That app is going to send the request. And you remember that I said the gateway is the thing that does the governance that we set up, right? And so the gateway has various types of configuration that we set. So I'll just talk through some of these examples here. So I've got rate limiting set up as a governance policy. What does that actually look like? It's pre-configured logic. So you don't have to write any code. All you're doing is configuring it. So you're saying for rate limiting, let's say, my rate limit is 5 requests per minute is my rate limit. So anytime I go over 5 requests per minute, I get rate limited. And so that's just a configuration, but it's a policy that I add into my environment. I can do things like apply quota. So if who's got a internet provider that says, hey, you can only use 1 terabyte a month of bandwidth, right? That's what a quota is. So similarly, I can set a quota on my API. Let's say you're only allowed to call 10,000 times in a month, or you can only use 1 gigabyte of data when you call that API. If you're using things like OAuth, which is an authorization and authentication capability, you're going to be familiar with this validate JWT. JWT is Java Web Token, and it is a format of authentication token that you can use with OAuth and OIDC. Maybe there's some caching that you want to do as part of your API call. Maybe you want to set a header in your API call, or maybe you want to set which backend API to route to. And so there's a couple other dotted lines here. This validate JWT policy might rely on another piece of configuration called a named value. A named value is just like a key value pair that we maintain. Or I can set the backend to my backend number 1 or backend number 2, and that's in the backend store. That's another configuration. So as my app is going through, we're going to apply some or all of these policies. So let's do that. I highlighted the ones that we're going to apply. So in this case, we're going to rate limit this one. We're going to take in an authentication token and validate it. That's going to use a configuration value. We're going to log that request, and we're going to route to a particular backend. And so when I make my API call, API management is going to, based on your configuration, it's going to choose which of those components to include in that request so that you have a little bit more control over the shape and activity of that request. Does that make sense? Any questions on how this works?
Yeah, for the cache, where does that cache live? Is it on the APIM? Do we have access to that or any kind of?
You don't have access to it. There is options. You can use cache that's built into the instance, and the amount of data you get with that built-in cache varies with the SKU of API management that you spin up. Alternatively, if you have a Redis compatible cache outside of API management, you can externalize the cache. So you can set up API management to point to that external cache.
That's like baked into the cache policy. It's not a
That's right.
C# fragment.
It's not a fragment.
Cool.
Any questions on this?
Yeah, is there a way to debug this locally somehow?
There is.
Awesome.
So there is a Visual Studio Code plugin.
Okay, sweet.
And so what it will let you do is it will let you debug these policies locally. So you'll be able to kind of step through the policies and see what's happening with your request as you kind of send it through the environment.
Okay, cool. Do I have to connect to the Azure environment?
Yes, you do have to connect to the Azure environment. That's like a live debugging scenario. But it does happen locally on your machine, so you can see the code or the XML document really that you've set up.
What kind of permission did you need for that?
Well, it's wherever you can run Visual Studio Code. So pretty much everywhere,
I'm not,
including in your browser.
if I do that, I'm not serving as the APIM. Like it's only my traffic that goes through my box or all traffic.
That's a good question. I don't think it's all traffic, but I don't know. That's a good question. I'll maybe get back to you on that one.
What about some of these securities such as SQL injection or cross-site?
Yeah, it's a good question.
Those gets blocked as well? Or is there a way to?
So it depends. So we have an article. It's on the OWASP top 10, which is like the top 10 most vulnerabilities that are most common for APIs. And for each one of those, we give guidance on how to mitigate that risk. And so for some, you can do things in API management to help mitigate the risk, like put in place a policy, right? So like, for example, if you know that there's an attack surface in a header, for example, a server name or something, you pull that out of the header. That's one way to mitigate that risk. But when we talk to customers, very often, we will ask that customers put what's called a web application firewall.
Is it like a application gateway?
Like application gateway in front of API management gateway. Right, and that does more of the, that'll do detect SQL injection attacks, for example, in your API requests. And we'll block those or at least log them.
So this becomes kind of additional to application gateway, and you
right
put this in the back and then manage everything and then give it to very backend basically.
Correct. Yes, this would sit between that front application gateway and the.
Gotcha. Thank you.
Well, before I get to this one, wouldn't Defender for APIs, would we want to use?
Defender for APIs is another good option, but that is more reactive. So it is going to detect potential nefarious activity and that will alert you of that. But it's not going to necessarily block that activity. So that's the kind of the distinction.
What is Defender for APIs again?
It's a good question. So Defender for APIs is a part of the Defender suite. Defender is a security suite within Azure that has a variety of different capabilities. Cloud posture management. Yeah, I'm not a security guy, so thank you.
All right, the question here is actually on API ops. Are you going to cover that later or?
I had not planned on covering it, but I can answer a question.
Okay.
So but maybe for the audience, API ops is the way that you manage the configuration of your API management environment through DevOps. So if I want to manage these policies and the APIs that get published and all of that configuration, you can do that through DevOps.
So Amando has an ARM template for their API gateway. Is API ops a better way of doing it?
Absolutely, a better way to do it. The reason is ARM is a little bit esoteric, and API ops is much more developer friendly. So for API ops, the things you need to maintain for an API are what we call an open API spec or a Swagger document, a little bit of metadata that's in the form of a JSON file, and the policy document, which is XML. So if you have those three things, you can manage pretty much the entire configuration of your API. So you check that into a repository, and then API ops will take care of deploying that to your. So yes, absolutely, that's the way you should go. In fact, the old ARM method is deprecated now, and so the tooling is not being. All right, so let's do a quick demo. Oops. So I'm going to go into my browser here, and I'm going to refresh my Azure portal. And this is an API management instance. What you'll see here is like this is one resource within in Azure. But those three kind of pieces, you don't actually see those anywhere. The reason why is it's one service. However, that's why I like showing that diagram, because it shows you the differences of API management. So in API management here, I could go to my overview page and look a little bit more about my instance and get my gateway URL and things like that. But really, I'm mostly interested in my APIs. I've got a couple here that are for later demos, but we're going to add a new API to our environment. So I can click on this Add API button, and it'll take me to this page. And you'll see a whole bunch of different options here. So we can just start from scratch. We can build out an API that's a plain HTTP API, and then we can add all the various operations like get and post and et cetera. And then we have a couple of other options. We have WebSockets. If you're familiar with WebSockets, we have GraphQL. If you're familiar with GraphQL, those are other options for the types of APIs that we support. Or we can come in and add an API from an existing definition. So most common one is OpenAPI, Swagger. If you've heard of a Swagger document, that's what a Swagger document is, an OpenAPI document. Some older legacy ones here around WSDL, which is a SOAP API that we were talking about earlier, or OData if you're an SAP. If you work with SAP, you're familiar with OData. So we can pull in those types of specifications into our API management. Or even better, if I've got an API that's sitting in Azure already, in the app service or function, I can pull those directly into my API management environment. And just as a spoiler, OpenAI is there as well. So I can start pulling OpenAI instances into my Azure environment. But for us, we're going to add a Swagger document. So I've got an API here that has a Swagger document, which we will pull into our environment. So I'm going to click on Open API. I'll paste in a link to my Swagger document. And you'll see that it'll automatically pull in the display name and a unique name. And it will pull in all of the documentation. So all I did is copy and paste a link to a Swagger. I'm going to go ahead and create my API here. And what that's going to do is it's going to populate my API in my environment. So you have that colors API, and you can see all the various operations that are part of that API. And they all got imported automatically with that Swagger document. Now I'm going to make a quick update to this so that something we're going to demo here is going to work in a second. So I'm going to add some products. Go ahead and click save.
Does your Open API have a limit to the number of endpoints that it can incorporate?
There is a top end limit, but I'm not 100% sure the number. But yes, there is one. It also only supports Open API version 3.0 series. So it doesn't support 3.1 and newer. Okay, so I've got my API, and I'm actually going to use this API on this website. So you may have seen this. If you came to my last talk 2 years ago, you might have seen this already, but hopefully you've forgotten about it. But we're going to do something. We're going to populate this application. What this application does is it's going to light up the dots on the page by making an API call. It's going to make an API call, get a random color, and then display that color in one of the dots. And it's going to do that a bunch of times. So I'm going to make a quick update to this. You'll see that it's already configured with my API URL. But if I call it now, you'll see that this subscription key is empty. So if I do that, what's going to happen? You'll see it says failure. Reason why it says failure is there's no subscription key here. So I've kind of gone and done this already just to save myself some time. But I have a subscription called the starter subscription. So let's grab that key. And I will rotate these keys. So if you see this later, key will not work for you. But I'm going to go here and add my key into the configuration. So let's just paste the key in here and then save. All right, and now I'm going to run this. And like I said, it's going to go call the API, get a random color, and then display that color on the screen. Oh, it did it 5 times and then it failed. Why did it do it 5 times and it failed? Well, I put in a policy, and let's talk about that policy. So if I go to my API product, and I look at the starter product, and look at the policies that are part of the starter product, you'll see that I added a rate limit. That rate limit says basically you can call 5 times. You can call 5 times within a single minute. And if you try to go beyond that, it's going to rate limit you. So we can try again. I don't know if it's been a minute yet or not. Let's reset this and start it again. It hasn't been a minute yet. But in about a minute, it will allow me to run it again because I've gotten past the rate limiting. That being said, I've got another subscription or another product called Unlimited, and I've got a subscription to that product instead. So why don't we go take a look at that? So we'll instead grab the key from the Unlimited subscription. We'll plug that into our colors website. Now when we start it up, it's gonna call a bunch of times, right? So now it's gonna fill up the page. with calls. So you can see I'm getting 10 calls per second. For example. Yeah, go ahead.
I might have missed it. Was the rate limit policy baked into your Swagger file, or where did that come from?
No, it's a policy that was already in my environment. It's something that I added.
Global policy?
It's a product level policy. So you brought up a good point. So API management has a policy hierarchy. So I can set a policy at the global level, at the whole instance. I can set it at a product. A product is like one or more APIs grouped together. I can set it at an API level, or I can set it at a operation level, like a get or a post. And so I can set that policy wherever in that hierarchy I want. And the other things that fall under that hierarchy will inherit that policy. So let's say I set something at the highest level. I can set it at the highest level, and my other policies or my other APIs will inherit that policy from that top level. Yes.
Does that include policy fragments?
Policy fragments just get, real quick, let me just tell everybody else what policy fragments are. So policy fragments are a specific configuration of a policy that you can save as something that's reusable. And so if I have multiple APIs that need to use a particular policy, I can save that as a fragment, and then I can just reference the reusable component wherever I need to. Now, you can insert those wherever in the hierarchy you want. So I could set a reusable policy at the global level. It's not super useful if it's at the global level because it will get inherited. But I could do that if I wanted to. But really, it's more about making that thing reusable than it is about where it sits in the hierarchy. Any other questions?
Hey, but these policies, they don't have to be created in the pool. They can be in the repo and through infrastructure as code deployed there, right?
Policies?
Yes,
Yes, they're basically an XML document.
right. Okay.
Yeah, they can be checked into code. And for example, if you're using API ops, that'll automatically get added. We'll look at this here. This is what a policy document looks like. XML.
Yeah.
And if I want to take a look at what the inheritance of this looks like, I can look here. If I set my scope to product, and I select the starter product, for example, then you'll see my rate limiting that happens for this policy.
Okay, thanks.
That can be stored in a repo and deployed automatically through the API ops feature. Okay, that was just a quick demo to give you an idea about how policies work and how they're used. And I set that up because a lot of what we do with generative AI is based on policy, right? They are just other policies you can use.
So just a quick question about costs.
Yes.
What is the, I guess, the standard expected cost to use this functionality, like the APIM, based on the number of APIs and the frequency of calling and all of that?
So that's very complicated because we have multiple SKUs, like 10 different SKUs. And there are two types of SKUs. There are classic SKUs and there's V2 SKUs. So in the V2 SKUs, for the most part, it is a standard fixed cost that has a standard amount of traffic. And if you go beyond it, you pay a little bit more. But that's how it works in the V2 tiers. In the classic tiers, there's just a cost no matter how much you use. So there's a slight difference.
What's the range? Like,
It's a
and
big
I
range.
ask because the SaaS vendors is also trying to charge us for using the APIs, right? So what's considered acceptable price point?
So, I mean, it varies from the developer SKU is the cheapest at, I think, $47 retail per month. Going up to premium V1, because premium V2 is still in preview. Premium V1 is 2801. That's a specific region. It depends on the region you deploy it to. So $2,801 for the premium SKU per month. So it just depends on where you land in that range. But the developer SKU you don't want to use for production environments. There's a basic, a standard, basic V2 and a standard V2.
Is what he's looking at, is that available for us?
Yes.
Yes.
So can you paste the URL to this in the chat?
Oh, wow.
Yeah. So Adam will put the pricing. These are retail prices. Your organization might have different prices. Okay. So let's talk a little bit. Sorry, did I answer your question?
Yeah.
So let's talk a little bit about Gen AI. So far we've been talking about APIs more generically, but Gen AI truly is running on APIs. When I call OpenAI, I call an API to use the LLM. I call an inference API to use the LLM, right? And so this entire world of Gen AI is really built on top of APIs. So just how I need to govern and manage APIs that live outside of the Gen AI world, I also need to do that for Gen AI APIs as well. So very commonly, if you're building an app, you're going to use something like an OpenAI backend. You're going to use maybe Azure AI Search. You may use Cohere to do model evaluation. So you may use a bunch of these different capabilities, and almost all of them are going to be exposed to you as an API. You're going to build an app that calls these APIs, right? So if we're going to take that a step further, let's talk a little bit about OpenAI. We'll just use this as an example, and I'll talk a little bit about how this gets extended beyond just OpenAI. But very commonly with OpenAI, you'll run into two scenarios. One, there's a bunch of models, right? Every several months, they're going to announce a brand new model that has more and more capabilities. So just going back about a year, most customers were using GPT-4. Probably most customers these days are using GPT-4o, and there's newer models coming out as well. And so the model range continues to grow. It's not just text models. There's also image models like DALL-E, and even GPT-4o in the multimodal capabilities. So in a single model supporting things like voice and images, right? So a bunch of different types of models, a bunch of different types of shapes. Additionally, OpenAI has its own concept of tokens and quotas. Now, when I say tokens here, and when we think about rate limiting in an LLM sense or a generative AI sense, almost always it's not requests per minute, right? When we talked about and we showed the demo, that was like 5 requests per minute. For an LLM, it's never going to be like requests per minute. It's going to be tokens per minute. And a token is a measure of the amount of data you're passing in. It's like 1.7 characters long is a token, right? And so tokens are what are going to be the currency that we use to exchange for LLMs. And so we have to rethink a little bit about how we manage some of those capabilities when we're thinking about LLM traffic or Gen AI traffic. Then OpenAI in and of itself has its own ways of deploying. So early days, almost everyone was using what we call pay-as-you-go or pay-go, which is I spin up an instance and then I pay for how many tokens I use, right? Nowadays, there are multiple types of deployments. Paygo is one of them, but you also have global deployments, which that is, I take a request and I will serve it from anywhere in the world. There's data zone deployments, which is the same thing, but a smaller geographic region, let's say in the US. So I'll take a request in the US and it'll be served somewhere in the US, but not guaranteed to be in a specific region. Then we also have what's called provision throughput. Provision throughput is basically guaranteed traffic levels. So if I have a highly important application that I'm using with Gen AI, provision throughput guarantees me a certain throughput. And then accessing those APIs, I'm going to access them directly through an API, or I'm going to use very commonly SDK. Right, I'm going to write a Python script, and I'm going to use the OpenAI SDK to connect to my Gen AI API. All right, so let's say I'm building a Gen AI application. If I'm building one, I've got an app, I've got a large language model, and I connect those together through an API, and I'm good to go. Very easy to do, right? But as soon as, and we learn this from ourselves and from customers, as soon as I have more than one app, and maybe I have more than one OpenAI, this becomes a little bit more complicated, right? I've got multiple lines being drawn across the app because I've got multiple apps and maybe I'm connecting to multiple OpenAI endpoints. And so very, very commonly, the scaling becomes a challenge. How do I do things like track how many tokens are being used? How do I do things like manage and load balance across multiple OpenAI? How do I handle authentication and authorization? How do I do rate limiting based on tokens? Those are all things that very commonly we encounter as we were using these technologies, but also as customers were using these technologies. So we're going to use API management for that. And what we've done is introduced, if you remember the anatomy of an API slide, we've introduced different pieces of configuration that you can use in your environment to handle these scenarios, right? So we're going to talk about each one in a little bit of detail. I hopefully won't spend too much time because I think we're pretty close to
8-ish.
8-ish? Okay. Okay, cool. We have time. So we'll talk through each one and hopefully you can understand how they're being used, and we'll demonstrate each one. Not each one. We'll demonstrate some of them. Okay. So the first one we have here is what we call the token limit policy. This is your rate limiting, right? But like I said, rate limiting here isn't requests per minute. Instead, it's tokens per minute. So I'm setting 1,000 tokens per minute as my rate limit, which means I can send in roughly 1,000 characters, send in and receive back. Roughly 1,000 characters, and that will be the limit that I impose on applications calling my API.
Your arrows there only go that way though, so it looks like that's only in. There's no,
Yeah, so
like there's a limit out.
yeah, so it's a little bit interesting because on the inbound, I don't necessarily know the exact number of tokens that I've sent in. OpenAI will report it back to me when I've come back out, which is exactly why you have this little bit right here, estimate prompt token. When I send in the prompt, API management can estimate, it's pretty close, how many tokens are being sent in, and it will make sure to include that in my rate limiting. That way it's more accurate. Yes, column. You'll also see there token quota. So very commonly, people have questions about what's the difference between a rate limit and a quota. And the way you can think about it is a quota is going to be aggregate. It's going to be across a longer period of time. So in this case, I can say a token quota either on a daily basis, but more commonly, you'll see this be like a monthly basis. Like I have a certain amount of quota of tokens used across the month, which is like my bandwidth limitation that I get from my ISP, right? I can use a certain amount of things over a longer period of time. That's a quota. Rate limit is a certain amount of things over a shorter period of time. Yeah.
So for your quota, is it use the same counter key, or can you have a global quota as just like in total across all of my products and subscriptions?
So it's always going to use this counter key. You can do one or more of these. So if you wanted to do, like, you don't have to include quotas and rate limits in the same policy section. But you can. So depending on if you want to apply different. And then you can use the hierarchy levels to then apply as well, right? So you could do it at a product level. Questions on this? Yes.
Correct me if I'm wrong, but I think I've read in documentation for like some OpenAI models, you'll have a limit for your token input, and then there's a whole nother part for the processing and then the outputs there, correct?
There is a input, output, and total. Those are usually the three, like you'll get 3 headers back with OpenAI, well, with a call from OpenAI that you can track. I'll show you that in a second, in the token tracking. Other questions? Is this making sense? Why would we need something like this?
The quota period is daily or?
So you can say daily, you can say monthly, you can say hourly. I think you can say minutes. There's a list of what the aggregation total is going to be. So you have some flexibility, but this is just an example of what it might look like.
Is it for one model? And has multiple models.
Yeah, so good question. If you want to handle multiple models, you want to create multiple APIs. Because I'll show you in a second when we talk about load balancing. Generally, the model is an input to the API call, right? So you give a model ID and you call the API. And we'll leave it like that because OpenAI expects it to be that way. But when we do things like load balance, you want those model IDs to all be the same, even though you're going to separate instances. And so in those scenarios, if you want to support for 4.0 and GPT 3.5 or some of the older models, you want those to be 2 separate APIs.
I want to restrict this model to this number of this group of people, right?
Right. So yes, so even more reason to separate those out. And then you can do some things like validate the model ID that's sent in and kick it out if it doesn't.
So your customer base can be multiple levels of subscription, right? Like somebody pays more, they get more usage.
Yes.
You can actually set those things depending on which user is got into this API.
Yes, generally you would do that by creating another product. A product is a loose grouping of APIs. So it's many to many, have many products, many APIs, and they can all be combined in various ways, right? So I can have, if I have 2 APIs and 3 products, maybe one of them has both, one of them only has one and the other one only has one. There's all sorts of combinations. And so if you want to do things like apply different quotas, do it at the product.
So you can manage users too?
You can manage users.
Let's face it, the OpenAI is going to bill you and Azure is going to bill you, and how you distribute those costs to your users It should be based on how much they use.
But we'll talk exactly about how to do that in a second. Thanks for the segue, which is the token metric policy. So next thing we're gonna do is, it's important to understand how those tokens are being used, right? And so the token metric policy, what it will do is it will aggregate our token usage within API management, and then periodically send that into what we call app insights, which is our telemetry and observability solution in Azure for apps, right? And so when we capture that information, we might want to be able to slice that information based on a set of what we call dimensions, right? We may want to look at it by a user ID, or we might want to look at it by an application ID. Or we might want to look at it by the subscription ID, which is our API key. And so there is a set of out-of-the-box ones that automatically get populated with the correct value, or we can set that dimension custom. And if we set it custom, then we populate it with whatever value we want to populate with. So that could be something in the header of the request. That could be a username that's in the token that gets sent in. It could be anything about the request that we want to use to look at our usage across time.
Is it possible to set up the cost?
So this is just going to give you information about how many tokens are used. So if you have a cost center, for example, if that is part of the request, let's say it's a header that you pass in.
Extra.
Yeah, an extra header that you pass in. We can certainly use it here. If you could go look it up. I don't know that I would recommend doing a whole bunch of logic in the gateway level itself, or the gateway layer, because anything you do there adds latency. So as much as you can pass in that information, you can use it as a dimension here.
Also, this is also the API management. Is it support for open models also?
Great question. So I'll answer that question in. Okay. Any questions on this? All right, so now we're rate limiting, we're monitoring our usage. What we may want to do next is load balance across multiple of these OpenAI instances. This was very, very, very common in the early days of Gen AI. And the reason it was common is because GPUs are hard to get, and there was not a whole lot of capacity for OpenAI requests early on in the process. The need for this capability has been reduced a little because there are features in OpenAI that solve these kinds of problems. But I would argue to most, this is still useful because it improves the user experience. And I'll explain how it improves the user experience in a second. So the idea here is OpenAI, you may have multiple OpenAI instances. These OpenAI instances have a set rate limit or quota that they are managing themselves. And once you hit the rate limit or quota for a particular instance, you start to receive error messages back. It's called an HTTP 429 error, if you're familiar with it. It means been rate limited, right? When that happens, the user gets a 429 message, which is not, you can code your application to deal with that, but should you do it at your individual application, or can you do it at a central layer? You can actually do it at a central layer, and that's why I would say probably I would still recommend setting something up like this because it allows you to make sure that your user experience is better. So how do we do that? OpenAI will send a 429 if it's rate limited. It may also send a 500. Let's say there's an actual server error that's happening. So it may send us a 500 series error. Server error, right? So we define, it's called a circuit breaker policy. It's not an API management policy. It's just what error messages do we react to is what that is, right? So what we say is when we set that up, we say, anytime you see a 429 or a 500 or greater, cut the circuit, basically stop sending traffic there. OpenAI will actually send some information back when it sends a 429. It will tell you, retry after X number of minutes, like 5 minutes. So what we do is we break the circuit and we save that information about when I should try again. So in and of itself, that's useful. But maybe we have 2 of these. And if the circuit breaks on that one, we want to send traffic to this one. So the second part of this is this feature called load balancer. Really, what this is called a load balance pool. Right? This is a pool of endpoints. One of them gets rate limited. We break the circuit to that one. And instead, we send to the second one. And so the second part of this is a load balance pool. Now that load balance pool has some logic on what to do next. So if this circuit is broken, there's logic defined here that says what to do next. The simplest logic is round robin, if you've heard of round robin, which means just go to the next one. Just go to the next one in the list. There's other things. We can do priority. So backend number 1 is priority, but if the circuit gets broken, then we go to a second priority item, right? Or we can do this based on percentages. So automatically send 50% of the traffic to the first one and 50% to the second one. Or if you have multiple, say 50, 30. So those are your different options for backends and circuit breakers.
Set it on a timeout. If you get some latency in one.
Can you set a timeout? There is by default a timeout.
They'll roll over.
Yeah, but you can set timeouts at an individual API layer or API level. Questions on this? Okay, I'm not going to spend too much time here. This is a very infrastructure-y diagram. The idea here is API management has the capability of being deployed in a very, very secure manner, right? Which means private networking. If you're familiar with Azure networking, I can set up this whole environment to be private. So a user sitting out on the internet would not be able to access my OpenAI instance. The only way they'd be able to access it is through API management. We're not going to get into detail or weeds about how to set this up, but there is a capability that API management gives you to enable you to expose OpenAI APIs in a secure manner. Make sense? Yes.
Not necessarily related to these, so I'll just slot it in between your slides.
Yes.
At the company level, is there a scenario at the company level? Is there a scenario or good reason to have more than one APIM? In our case, we've created 2 different instances, 2 different business units.
So great question. What I would say, working with customers on this for a very long period of time, is you want as few of them as you can afford to serve your business needs. Now, there may be a very valid reason that your different business units have their own instances. Maybe that you manage APIs in like very different ways across those business units. But as few as those environments that you can maintain that still serve your business needs, the better. And the primary reason is it's a governance solution. And so if you just spin up a new instance every time you have a problem with how the governance is set up, you'll never govern anything, right? And so you just want to reduce the number of those instances, and so that as many of your APIs are being managed under one or a few of the instances as possible, so that you can enforce that governance that you want to put in place. Sense? There may be valid business reasons to do it. And so definitely we have customers that have deployed this at broad scale that have more than one instance. So it's not unheard of, but you want to try to keep it as few of those instances as you can. Make sense? No problem. All right, so let's talk about an interesting one here, which is this idea of semantic caching. So caching, people are very familiar with. Like I make a request to something that takes potentially a long period of time, and I save that request in cache so that the next time that I ask for the same thing, I get it out of cache instead of going to, let's say, a database or something to get that information. Now, that concept applied to Gen AI could be something that's interesting. But how common is it going to be that I ask my AI, or I prompt my AI with the exact same prompt more than or that multiple users are prompting with the exact same prompt more than once? It's not very common. And that's because people, when we're prompting, you're essentially writing a sentence or multiple sentences. And the variation of those could be broad, right? So the idea here is don't cache there where you take a copy of what was sent in originally and cache that. But you cache when things are semantically similar. And so when I say semantically similar, what I mean is that they mean the same thing, right? So if I ask, what's the best way to make coffee? And then I ask, what's the greatest way to make espresso? That's semantically similar, right? Now, whether it's similar enough to return a cached response, that's up to you to figure out. The way that you figure out is play with this configuration, which is a score threshold. That says how semantically similar is valid enough to cache something. We'll see an example in the demo in a second. The way this works is I send in a prompt. What I'm going to go do is first I'm going to generate what's called an embedding or a vector. That is a mathematical representation of the prompt that I sent. And then I'm going to check my cache, and I'm going to look for similar vectors in my cache. If there are similar vectors in my cache, I'll get the response from my cache. If not, then I'll go to OpenAI, send in the prompt, and then when I get the prompt back, then I'll cache it. Yes.
In case of generative AI, don't you want that to be different reply each time? Sometimes, like you generate picture, but you want to have different picture than you ask.
If you have two different pictures, are those going to be semantically similar? Probably not, right? Like two different pictures aren't going to be close enough to the same to return a similar response on the back end, right? Whereas if I'm sending in text and I'm asking, what's the best way to make, a coffee, or what's the greatest way to make an espresso? Maybe that's close enough to return the same response. And that's what it's doing, checking mathematically if the vectors are close enough.
Semantic cache lookup or any other types also?
So regular caching is available in API management. This is an extension of that using semantics. Questions? All right, home stretch. So someone asked, is it just OpenAI? I think you asked. No, it's not just OpenAI. It's anything that uses the AI model inference API. So within Azure AI Foundry, there's many different models, so 1,700, 1,800 models now. A subset of those are conform to the Azure AI model inference API. That API looks exactly like OpenAI's API. Pretty much looks exactly like OpenAI's API. And so we have these same features available for that API. In fact, anything that looks like Azure, or it looks like OpenAI's API should work with these features that I mentioned. We don't limit it. We don't test every API, but if it follows the API, OpenAI API shape, then these features that we just talked about should work with it. Sense?
Does it work with on-prem, like, if I hosted the LLM?
If you have network connectivity to that on-prem from API management, then yes. All right. Always struggle a little bit with these Gen AI demos, because how do I demonstrate load balancing? Well, I have a way. Is it the most interesting way? That's a good question. I'll let you guys tell me. All right, so in my API management instance, I have a couple of APIs that I've already set up. I have OpenAI, and I have an OpenAI semantic cache API that we're going to use, and we're going to test them. We're going to test them using some Python notebooks. Does anyone know what notebooks are? People have used Jupyter notebooks.
I've never heard of it. What is that?
It's a way to interactively test out code, write code, and then try it. And it all it makes it documentation. It's a really good way to learn. And you will see it a lot in data science and AI applications. And so we're going to use one. I'm going to actually adjust my resolution here. Sorry, go ahead.
The Microsoft term is notebook, not Jupyter notebook,
All right.
so that you know.
Indeed.
Just plain vanilla.
Okay. So, I'll just quickly walk you through these notebooks. There is, at the end of the slides, there is a link that I will share. And one of the links on this page, the landing page, is to this repo that has a bunch of these notebooks. What you can do is, once you have the notebook set up in your environment, you can run all of these same experiments that I'm going to show you within your own environment. But I've already gone through and done most of the steps here. Basically, this goes and deploys all the things you need to play with this. And then what it's going to do is it's going to help you generate some traffic. So indeed, I'm going to call the APIs that I just created a bunch of times. In this case, demonstrating load balancing. What this is going to do is going to call my API 20 times, and it's going to show how we load balance. And indeed, the way that you're going to be able to tell it is that for a period of time, it is going to go to our primary instance of AI. Then after that period of time, it is going to start alternating between our second and third instances. Because it's essentially load balancing. That first one, quota was a rate limit, we hit our rate. And so it is waiting until the rest of the calls are made. And so we're going to try to recreate that experiment, that graph you just saw. And so what I'm going to do is I'm going to run this. What this is going to do is you see here, every time I make a run, it is going to show it on this page. You see there? Number 9, it's not live, so it's going to go in the background. I actually hit a 429 in my environment. 17, 18, 19, 20. Okay, so you'll see that I made 20 different requests. I get some information about how many tokens are used. I get the prompt. I get some information about what's happening, but most importantly, I get a indicator as to what region my request was sent. So now let's take a look at that data. I'm going to do some analysis, and this is where Python is super useful, because what I can do is just create a chart. This is a chart based on the data that I just ran. So you can see here, mine are East US 2, West US, and Sweden. You'll see my first API was used up until the 13th request. Then beyond that, I alternate between my second and third APIs. So indeed, I've now load balanced across 3 different OpenAI instances, making sure that all of my, or as many of my API requests as possible return a response from my users. Sense? Questions on this? Okay, so the next one is token metric usage. So now I want to track how many tokens are being used when I make an API request. So in this case, I'm going to run some requests. In this case, 10. I'm running 10 requests. You will see here. 10 of 10. I ran those by directly calling the API. Now I'm going to do the same thing, but I'm going to instead call the SDK. So just to show you that it works both ways. Let that. This is going to call using multiple subscriptions. You see here, it is referencing more than one subscription as it's making these calls. Now let this run. Slow. Looks demos, but my failing wants to spite me. Yes. There we go. Okay. Move forward. In this case, I've told it that it is a sarcastic assistant that is giving me sarcastic answers.
To what is the time?
Yeah. Oh, sure. Let me just look at the time. Okay, we'll let that run and then let's look at the results. And I'll show you the Python way of looking at the results, and then I'll show you the Azure way of looking. Normally, you run these experiments individually. This particular experiment, I don't think is meant to be rate limited. So I think it's actually being rate limited. Almost there.
One question before.
Yes.
Before the finish. I mean, these days, agentic thing is becoming more popular AI. And do you guys use any of these
Yes.
techniques? And
We have many ways of building agents. So we have a low code way or no code way called Copilot Studio. So if I wanted to build an agent, I can use what's called Copilot Studio. That's part of Power Platform. If I want to use a coded way of doing that in an enterprise ready fashion, then I can use Azure OpenAI agents or the agents service within Azure AI Foundry. And then if I want to build custom agents, we have a couple of different frameworks. We have semantic kernel. That's the one that you want to use in production environments. And we have AutoGen 4, which is the experimental model that we use, that you can use to experiment and prototype. And then that is going to start becoming a part of semantic kernel as well. Then we have a variety of different other experimental ways of looking at Magentic one or some of the other capabilities. So yes, we have many.
or integrating with Kubernetes is a load balancing.
A lot of them do work with, like, if you wanted to build it in semantic kernel, you could, and then deploy that in Kubernetes. So this is just tracking my token usage and plotting it. That in and of itself is not super useful. But let's show you the way to go look at that data in App Insights itself. So I'm going to refresh the page here. I need to rebuild out that. Okay, so I'm going to reduce the time range. I'm using in Application Insights the metrics capability. I'm going to go to OpenAI metrics. And let's say I want to look at total tokens used, aggregate sum, and then I'm going to apply filtering. If you remember those dimensions, these are the dimensions. In this case, I'm going to filter by subscription ID. And so what I can see here, maybe I can go even. I can see the individual usage of tokens over time. And I can also aggregate that token usage over time. So I can say, hey, for subscription 1, at 7 p.m., 7:28 p.m., I use 777 tokens. And then at 7:29, I use 252. And then it was over. Then maybe I use 52 more a little bit later. And then I could aggregate this by, a certain period of time, like a month. And then this would give you the data you need to do things like cross-charge. I think there's a question about using a cost code or something. Any questions on this? Last demo here is around semantic caching. So I'm going to ask similar questions. So I actually already previewed this. How to brew the perfect cup of coffee? What are the steps to craft the ideal espresso? Tell me how to create the best steaming Java. Explain how to make a caffeinated brewed beverage. So semantically similar requests, maybe close enough to give us the same response from the LLM. And especially at scale. So let's say I put a chat bot or something on my public website, and that chat bot is asking, people use that chat bot to ask questions. Very commonly, you would want to use a model like this so that very similar questions get answered the same way for you. So I'm going to run this experiment. What it's going to do is it's going to ask the question, and you'll see that the first one took a long time to come back. All of the other ones were pretty quick. Let's just make that a little bit visual. You can see that first one took 5-ish seconds to come back. Every other one, since it was cached semantically, was very, very quick, right? Almost instantaneous return. And so we can get a lot of performance out of our environment using this technique. Sense? So, I don't really have any left. I will share this link with you all. aka.ms/APIM love. This is basically a landing page for API management. We post all the new things here. So videos, it's one of our colleagues, John Saville, who you may have seen his videos before, who has posted a deep dive on API management. He's done a deep dive on all these features that I just explained to you as well. But there's also news, blogs, links, and there's a link to that notebook repository that I used to show you some of these experiments. You feel free to grab that, pull it down to your environment, and run the experiments on your own. including an experiment on model context protocol. Model context protocol for everyone else. It is a common way to provide context to LLM to perform triple augmented generation, right? So LLMs are trained on large amounts of text material, but they're only trained up until a certain point in time. So let's say GPT-4o, I think, is in 2023, October 2023 is the last set of information it has fresh. And so if you're looking for new information, you have to augment that information to the LLM. Very commonly, the way you'll do that is to give additional context sources to the LLM. And so model context protocol just unifies the method by which you make that information available to the LLM, so that you can build once and share amongst all of your different LLM applications. To do that, like today, you would do that one-off, right? Build those integrations. One by one. Alrighty. So,
Any other questions? Yeah, thank you. Yeah. Thank you. Comment. Go ahead.
Before you all leave, can I have a picture so that I can, for memories? That's
you want to do that?
And then do a selfie from there. Okay, fine. We'll do what Kim wants. What Kim wants.
Yeah. Okay, maybe we can line up with that APIM love and then between Adam just kind of stand.
Over there.
Yeah. I can have my picture.
Got it.
So my employee who sponsored the event tonight.
For the pizza, okay? So we pay for the pizza. So this is what.
I would appreciate it very, very much. Okay, I'm gonna call the kids so they can get on the cover. Hey, boy.
Crap, obligated. Good.
Thanks.
We do this all the time. Totally normal. Normal.
Picture.
Oh.
Yeah. I want you to take pictures, but please. No.
Oh, yeah, that's
Quick.
fair. Yeah.
Appreciate that.
You guys want me to get like from the patrol?
Yeah.
Well, people can get in there, right? Stand in front of Mark.
Maybe you go far back. I need to stand on a chair and like far back. That'll work.
Make sure you just push the button. Thank you.
And no bunny ears, okay?
No one here.
Health and safety, who needs it?
Say cheese pizza.
All right.
3, 2, 1.
Okay.
Okay, now a wild one. 3, 2, 1. What are you gonna do? I'm gonna do like Azure, right? All right, there we go.
All right, thank you
That was
very
more
much.
fun. You know which one they got. Thanks, everyone.
Thank you for the pizza.
All right. So we'll be next month with Kim. We have a speaker. Kim, who is it next month? Kim? 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 Kim. Who's next month?
That would be, I'm sorry. Let me rephrase.
This is fine. So we have a speaker for next month. We're blanking temporarily. Check the meetup site.
No,
Gonna-
actually, it's gonna be one of our MTC architect on.
Oh, yeah, that's right.
Pilot security.
Co-pilots. Yeah, here next month. So, yep. Thanks for coming out, everyone. Thanks for coming online. Hope to see you here next month. Thank you all.